Hello everyone, welcome to Edureka YouTube channel. My name is Saurabh and in today's session I'm going to focus on microservice training. So without any further ado, let us move forward and have a look at the agenda for today. So this is what we'll be discussing today. We'll begin by understanding what is the use case that we are going to implement in today's session. After that, I'm going to tell you about the few basics which are required in order to execute that use case, like what exactly is microservice, what is monolithic architecture, what is Docker and how Docker can be used in microservices. And finally, I'm going to tell you how to implement the use case using Docker. After that, I'm going to discuss the course content of microservices training provided by Edureka. So let's move forward and have a look at the use case that we are going to implement in today's session. So this is a problem statement of our use case, guys. We have a Node.js application and MySQL database running in the same instance, or you can say in a local laptop. So this is a typical example of a monolithic architecture. So let us just focus on few problems with this architecture and then we'll see what is the solution to it. So let us now discuss the problems associated with this monolithic architecture. I'll just give you a small introduction to all of these challenges. Later on, I'll discuss it once more when I'm talking about monolithic architecture. So I hope that is fine with you all. So the first thing is large and complex applications. So if the size of our application is pretty large, then it becomes really complex to understand and modify such applications when you use a monolithic architecture. You'll actually understand that when I'm talking about monolithic architecture in detail, you'll understand why are these problems there with such an architectural pattern. Then it also leads to slow development. As the application and the respective teams grow, the application becomes difficult to understand and modify. And also the larger the code base, it leads to slower ID. Then at the same time, it blocks continuous development as well. And it is pretty unscalable. So each copy of the application instance will access all of the data, which makes caching less effective and increase memory consumption and input output traffic. Also, different applications components have different resource requirements. For example, one might be CPU intensive while another might be memory intensive. So with the monolithic architecture, we cannot scale each component independently. Then it is pretty unreliable because of the tightly coupled components that we have here. All right, so if any of the component goes down, the whole application will fail to run. And then finally, it is inflexible as well. So with monolithic architecture, it becomes really difficult to adopt new frameworks and languages. So this is a problem statement of a use case, guys. Let us see what is the solution to such a problem. So it is nothing but microservices. Now what I'm going to do here is I am going to create two separate services, one called user service, another is test database running on a different Docker container. All right, so with this, what we have separate services, or you can say we have separate microservices compared to a monolithic architecture that we had just seen. So what I've done here is this monolithic architecture where my Node.js and MySQL were running on the same instance, I've divided them into two separate microservices. One is user service, another is test database. And both of these services are running on a different Docker container. So this is nothing but an example of microservice. So this is the use case that we are going to implement in today's session, guys. If you have any questions or doubts, you can go ahead and write it down in the chat box. Apurva, Jagrati, Sohail, Adam, Dave, any questions, guys? Quinn? All right, Quinn says he has no doubts right now. So I can see that few people have raised similar questions. Jagrati and Pooja, even Adam has asked the same question. He's asking what exactly are microservices? Can you please explain with a use case? Definitely, just be a bit patient. I just wanted to discuss the use case that we are going to implement in today's session. Let me just cover all the fundamentals for you. So now we are going to compare before and after microservices. Basically, we're going to find out the differences between the microservices and the monolithic architecture. So let's begin, guys. So let's take the classic example of an e-commerce website. Now from the diagram also, we can observe that in the monolithic architecture, we have all the features running under the same instance. For example, we have customer service, we have product service, we have cart service. Right? All of these instances are running on a single instance and sharing a common database. All right, so this is a typical example of a monolithic architecture. But then with microservices, each feature was allotted a different microservice, which handles their own data and performs different functionalities. All right, so this is the basic difference between the monolithic and microservice architecture. So the idea behind microservice is that few applications become easier to manage when they're broken down into smaller composable pieces that talks to each other. So that is what exactly microservice is. Now let us move forward and we'll understand microservice architecture in a bit more detail. Now before this, if you have any questions or doubts, you can go ahead and write it down in the chat box. All right, so I have a question from Dave. He's asking, in microservice architecture, the different microservices, they share data structures or not? Well, they don't share data structure, Dave. All right, they communicate through APIs. That's the answer to your question. So I hope you're satisfied with it. All right, he says thanks. Any other doubts, please write it down in the chat box. Fine, so I can see there are no questions. Let's move forward and we are going to focus on microservice architecture. So we are going to discuss it in much more detail. So let me discuss this architecture with you. Now over here we have different clients coming from different devices and they're trying to use services such as search, build, configure and other management capabilities. Now all of these services are separated based on their domains and functionalities and are further allotted to individual microservices. So you can see we have microservice A, B, C and D. Probably this is for your search service, this is for your build service, this is for your configure. Like that, we have many other services as well. Now, these microservices have their own load balancer and execution environment to execute their functionalities, and at the same time captures data in their own databases. So microservice A will have its own load balancer and execution environment and will have its own database as well. Similarly for other microservices also. Now, all the microservices communicate with each other through a stateless server, which is either REST or a message bus. Now, all the functionalities performed by microservices are communicated to the clients via API gateway. When a client gives a request, it will first go to the API gateway, and all the internal points are connected from this API gateway. So anybody who connects to the API gateway automatically gets connected to the complete system. So I believe, guys, I've given you a good introduction to what exactly are microservices, what is monolithic architecture, why we use microservices, what are the various challenges with monolithic architecture. So if you have any questions or doubts, you can go ahead and ask me. So I have a question from Jagrati. She's asking the use case we are going to implement in Windows operating system. No, we are going to use a CentOS virtual machine. I have it installed in my system and I've already installed Docker in it. All right, so I'll be using Docker for this particular use case. Any other questions, guys? All right, there's a question from Pooja. She's asking, what is the relation between DevOps and microservices? So let me tell you a few things first. DevOps is a completely different field. It's basically a software development methodology that bridges the gap between the ops team and the dev team. And its major aim is to provide good quality software in time and frequent releases, if I have to say. And without the microservice architecture, if you have a large application, frequent releases are pretty tough, right? There might be certain exceptions. But with microservices, you can frequently deploy your applications. You can quickly adopt changes. You can quickly take the feedback and incorporate that feedback and then deploy it again. So, DevOps methodology with the microservice architecture is something that is really required right now and something that people really appreciate and is highly adopted in the industry right now. All right, so she's satisfied with the answer. Fine, guys. So let's move forward. And now we are going to discuss what exactly is Docker. Now, what is Docker? If I have to give a definition, I would say at its heart, Docker is a software which lets you create an image. Image is nothing but a template for a virtual machine and then run instances of that image in a container. So that's what Docker is. All right, I have a question popped on my screen. This is from Quinn. He's asking, can you tell me the differences between virtual machine and Docker and which is better? Fine. So which is better? I would say Docker. Let me just give you a few reasons for that. First of all, Docker is pretty lightweight, right? You have all the binaries and libraries there in your container required for your application, which can be a microservice application as well. Plus, it's pretty lightweight. Plus, it doesn't use the guest operating system. It uses the host operating system, unlike the virtual machines. And you don't have to pre-allocate any RAM in the containers, unlike your virtual machines. So I believe I've given you enough differences between the two. Already satisfied with the answer. Now let me just take you through the diagram that is there in front of your screen. So here we have an host operating system. On top of that, we have Docker engine, right? So we have a couple of applications running on top of Docker engine. So we have a couple of containers as well. All right. So basically what we have done, we have containerized the two applications in two different containers. So we have binaries and libraries along with the application in one container. And similarly for the container 2 as well, we have similar configuration. So all the binaries and libraries required for your application are present inside a Docker container. All right, now let me just go ahead and discuss few components of Docker. So I'm going to start with what are Docker images and what are Docker containers. So Docker images, as I've told you, are read-only templates which are used to create containers. Now Docker maintains a vast repository of images called the Docker Hub, which is nothing but a Git repository of Docker images. Now with Docker images, we can create Docker containers. All right, and they contain everything required to run your application. Now this is all about Docker images and Docker containers. So let me just quickly open my virtual machine and I'll show you few basic commands of Docker. So this is my CentOS virtual machine, guys. Over here, I've already installed Docker. So let me just go ahead and quickly start Docker. So the command to start Docker is systemctl start Docker. So it has started now. Let me just clear my terminal again. And now I'm going to try out few commands and then exit the container. So now what I'm going to do is I'm going to show you how you can pull images from Docker Hub, right? So I'm going to pull Ubuntu image from Docker Hub. So let me just tell you how you can do that. All you have to do is click Docker pull Ubuntu. That's all you have to do. It will first check the local system if there are any images available. If there are no images available, then it will go ahead and check it in Docker Hub and pull an image for us from Docker Hub. As you can see that it is pulling from Docker Hub right now because it couldn't find it locally. So it says that downloaded newer image for Ubuntu latest, which means we have successfully downloaded the Ubuntu image. Now let me just hit a command called docker ps, and this will give me all the images, all the containers which are there in my system right now. Now if I have to run this container, what I have to do is I have to type in here docker run -it and the name of my image, or you can even use the image ID. So I am in Ubuntu container right now. So over here you can try out few Docker commands. I'll exit from here now, and yeah. So let me just clear my terminal again. So what we have done, we have basically pulled an image of Ubuntu from Docker Hub, and then we build a container from that image. That's what we have done till now. Let me just show you how Docker Hub looks like. So for that, I'll open my browser. Now this is the official website, that is hub.docker.com. You need to go to this particular URL and you can just go ahead and create an account for free and get started. You can find all the images. Plus you can upload your own images as well if you want. I'm just gonna type my username and password. I'll be logged into Docker Hub. So this is how Docker Hub looks like, guys. We have a couple of tabs here: repositories, stars, contributed, create a repository, create an organization, explore repositories. So just go ahead and play around with it and you'll understand it. I'm just going to tell you how to search an image here. So if I want an Ubuntu image, so this is the official Ubuntu image here, guys. Similarly, you can go ahead and search whatever images that you want. All right, so let me just close it for now. So we have just discussed what exactly is Docker, what are images and what are containers. I've also executed practically. I told you how you can pull an Ubuntu image and create a container from that. Let's move forward and we'll focus on Docker registry. Now, I won't spend a lot of time on Docker registry because it is nothing but a storage component of Docker images. Docker's own cloud repository for Docker images. Similarly, you can have either public or private repositories on Docker Hub as well. So it's basically a storage component for all of the Docker images. Now I'm going to talk about Docker Compose because this is what I'm going to use in today's session. Now, what exactly Docker Compose is, when you have multiple containers, then Docker Compose makes it easier to configure and run applications that are there in those containers. What I mean by that, consider the example that is there in front of your screen. So imagine I'm being able to define three containers, one running a web app, another running a Postgres, and a third Redis. Now all in one YAML file and then running those three connected containers with a single command. That's what Docker Compose is. So we have three applications and we write the configurations for all of these three applications. We have defined all of these three applications running on different containers in a Docker Compose file, that is Docker Compose.yaml. And then with one single command, I can run all of these three containers. That's what Docker Compose is. All right, so I'm going to show you practically how it works. So let's move forward for now. Now, this is basically a use case of how Docker can be used in an industry. So I'm going to write a Docker file, complex requirements for a microservice in an easy to write Docker file. Now from that Docker file, I can create Docker images and in turn run as many Docker containers as I want. Now that Docker image, I can upload that onto the Docker Hub, from which various teams, be it staging or production, can pull that image and prepare as many containers as they want. Now, whatever was there in my developer's laptop is replicated in my staging as well as in my production environment. All right, or you can say throughout the SDLC. So this is how you can use Docker. Although there are multiple use cases, right, available. So you can just, this is one way of using Docker, guys. Now Docker for microservices. So just an example how we can use Docker for microservice. Basically, imagine we have separate services for an online shopping service. We have account service, product catalog, card service, and order server, right? All of them have their own database. So we can run all of these services on a different Docker container. I'm going to show you practically how you can do that. So let me just quickly go ahead and discuss few advantages of Docker in microservices. So what are the various advantages that we get when we run Docker with microservices? So the first advantage is packaging. So a piece of software usually consists of a number of components. Now these components may be bundled together or distributed separately and are usually themselves composed of various files. This can include executables, binaries, documentation, etc., etc. Now, in order to make software distribution convenient, there must be some way of assembling all of these pieces together into one cohesive whole. So traditionally, this was done using one of a number of mechanisms like zip files or tarballs, Debian or RPM packages, or language-specific packages, for example, NPM, Python wheels, Ruby gems, etc., etc. So these all have their own trade-offs, but they have one thing in common. They do not solve the entire problem. Zip files need an agreed upon format for their contents. Debian and RPM packages are OS specific and notoriously difficult to work with. And the rest are the language specific systems that do a proper job of handling application dependencies outside of the scope of their language. Now, Docker makes it possible to achieve the granularity of portable microservices through its packaging. So I hope you got my point. Now let's talk about distribution. So in order to share software with others or to deploy it somewhere, the software package needs to be tracked in a central place and accessible across the organization. Now Docker solves this problem by providing a standardized API for a registry service as well as an open source implementation. For now, the standard Docker registry is not quite user friendly, right, and lacks some features available in other systems such as Yum and app. However, this will improve with time, and that will happen definitely, guys. Runtime isolation. Now, if you worry about efficient resource utilization, you're likely tempted to run multiple microservices per host. All right. Now, this is definitely doable, but can present some challenges. Let me discuss those challenges. So I'll just discuss one such challenge, which is called dependency management. For example, if service 1 requires a library with version 1.x, while service 2 requires the same library, but with an incompatible version 2.x, you'll likely run into a problem if you're using a package manager that installs packages system-wide, such as apt or yum. Some ecosystems provide a way to isolate the application environment into a specific directory. One example of this is Python's virtual environment. Node.js NPM also does this by default as well. However, the isolation offered by these systems is far from perfect. Any dependency on libraries or executables outside of the language's sandbox can still result in conflicts. Another issue that comes up when running multiple microservices on the same host is protection against rogue processes that use more than their fair share of memory or CPU. Prior to container technology or Docker containers, the main way to achieve this would have been to run multiple virtual machines, right? Now, Docker solves this dependency isolation problem by packaging the entire OS image along with all the dependencies. It solves the resource isolation problem by providing and enforcing explicit CPU and memory constraints. Similarly, Docker's runtime isolation allows you to run multiple API microservices side by side on the same host with greater ease and maintainability. So different teams working on different microservices will not affect the runtime of others. If I have to give you an example, think of it like if a revision of an API is needed, the API microservice running in a Docker container can be redeployed without affecting other APIs. And finally, the installation process. The last advantage of Docker in microservice is how simple it is to install. You can just go ahead and refer a few installation videos. You can find the link in the chat box, and the people who are watching it on YouTube can find the link in the description box. So these were various advantages of using Docker in microservices. Now let us discuss the implementation of the use case. I already told you what I'm going to do here. I have a monolithic architecture that has Node.js and MySQL running on one single instance. I'm going to create two microservices, user service and test database running on two different containers, and I'm going to run those containers using Docker Compose. All right, so I hope I'm clear, guys. If you have any questions or doubts, you can just go ahead and write it down in the chat box. I'll be happy to help you. Any questions, guys? So we have no questions. I'll just quickly open my virtual machine and I'll show you how I've implemented this use case. So this is my CentOS virtual machine again, guys. Now for doing local development, we'll need to install MySQL and create a test database for us. Now for local development, we need to install MySQL and create a test database. Now creating a local database and running scripts on it is an easy start, but can get messy. Lots of uncontrolled stuff going on. It might work. We could even control it with some shell scripts checked into our repo. But what if other developers already have MySQL installed? What if they have a database already with creative name users which we want to create? So because of all of these reasons, we are going to create a test database server in Docker. So I'll just tell you how to do that. So this is a great Docker use case, guys. We might not want to run our production database in Docker, but we can spin up a clean MySQL database in no time as a Docker container for development, leaving our development machine clean and keeping everything we do controlled and repeatable. So in order to do that, the command that I'm going to type in here is pretty easy, guys. Let me just go ahead and quickly do that. So it is docker run -name. Now I have to give the name to my database. So let that be DB. Then MySQL password I need to give, root password, which is equal to 123, whatever password that you want to give, just go ahead and do that. Now define a port here. So 3306 of my host and 3306 of my container as well. And the image, so I just want the MySQL:\latest image. All right, so it's pretty easy. So here we go. So it has started now. It is giving us few warnings. You don't need to worry about that. So this starts a MySQL instance running, allowing access through port 3306 using the root password 123. So we know that Docker run tells that the engine we want to run an image, and the name of the image is MySQL:\latest. All right, so let me just quickly open one more tab. And over here, what I'm going to show you is the image that we have just downloaded. So this is the name of our image. This is the port plus we have created it about a minute ago, right? So we can find all the details here. Now what I'll do, now let's connect to this image and see what's there, all right? So I'm just going to type in here docker execute -it. The name of my image is db/bin/bash, and here we go. Now over here, if I type here MySQL-user, that is root, and the password is 123. So you can see that. So over here, I'll just type MySQL databases semicolon. So MySQL database, I'm sorry, it will be show databases. By mistake, I've typed MySQL databases. So here it is. You can see all the information here, right? So what we did, we basically executed a docker exec-it db tells Docker we want to execute a command on the container named db. We can also use the ID or just the first few letters of the ID as well. And -it ensures that we have an interactive terminal. MySQL-uroot-p123 that we have given there is a command we actually run as a process in the container, which in this case is just the MySQL client. So we can create databases, tables, users, whatever we need basically. Now let me just move out of this. I'll just type in here exit and one more exit. All right, so we are done now. So till now, any questions, guys? Any doubts you have in your mind, you can just go ahead and ask me. So there are no questions as I can see. Now running MySQL inside a container has already introduced, few Docker tricks. So we are running MySQL inside a Docker container. So now what we need to do is we need to create a test database folder with a script to start the database, stop the database, and set up the test database. So let me just tell you what I'm talking about. So I'll just go to a particular directory. Now we'll have to create a test database folder with a script to start the database, stop the database, and set up the test data. Now for that, what I'll do, I'll just quickly go to a directory that is documents. Over here, I'll enter. So this is my application, guys. Let me just clear my terminal. Now over here, I have directory called test database. So let me just show you that. Let me clear my terminal. So over here, I have three scripts. One is to start the database, that is start.sh. Another is to stop the database. And then the final one is to set up the database as well. Now, let me just show you what I've written in each of these files. So let me just start with the startup script, start.sh, and you can use whatever editor you want. You can even use a cat command that will display it on your terminal itself. So this is a script to start my test database, right? It's pretty self-explanatory. You can go ahead and have a look at this. If you want all of these codes, you'll find the link in the chat box right now. And if you're watching it on YouTube, you can mention your name and the email ID in the comment section below. Edureka team will send all of these codes ASAP. All right, so this is my startup script. Now let me show you the setup script that I'm talking about. So I'm just going to do a cat command here, setup.sql. So this has all of my data. So it has my email addresses and various phone numbers and things like that. It is available here. So this is my setup script. Now what I need to do is I need to create a stop script as well, stop.sh. So here we have stop the database and remove the container. So docker stop db and docker remove db. So before removing any container, you need to first stop it, and that's what we are doing here as well. And then we are removing it. RM stands for removing the database. Now let me clear my terminal. So we are done with wrapping up the test database. Now we need to create a microservices in Node.js. So this video basically talks about how we can use microservices with Docker and what exactly are microservices. So I won't go into too much detail of Node.js application that I'm talking about. So let me just highlight the areas and takeaways. So I'll just go to a particular directory called user service, and let me just clear my terminal. So over here, you can see that we have multiple folders and files present here. So starting from package.json, so this is basically used for dependencies and metadata. Then index.js is nothing but a main entry point of the application. So we have API as well. So this API file includes our APIs and the API test. Then we have a config directory as well. This is basically the includes the configurations of our application. Then we have the repository directory, which provides the abstraction over our database. And then we have server directory as well that will contain the server setup code. This is how we have created the Node.js application. Let me just clear my terminal again. Now, if you want the code for this application, again, you can find it through the link that is present in the chat box. And if you're watching this video on YouTube, you can mention your name and the email ID in the comment section. We'll reply you ASAP with the code. So this application that I've built here is basically allows us to get all the users or to even search a user using the email. So in the setup.sql file, we have seen that I've given all the data, the email address and the phone number. So this is what my application is all about. It's pretty basic, but it's a very good example to understand why we should use Docker with microservices, right? So now let me just hit few commands. So in order to start that, I'll just use the startup.sh script that I've written. And here we go. So it is waiting for the database to start up. So it is done now. We have started our test database. All right. So in order to stop it, we can just use a stop script that is /stop.sh. And that's all we have to do. All right. So let me just open one more tab here. So over here, I'll just run my Node.js application. So let me first go to that particular directory. So all I have to do is here npm install. All right. So this will set up everything for me. So it is up to date in 4.826 seconds. And the next command is to start my application. So all I'm going to type in here is npm start. So server started successfully at port 8123. Now let me just open my browser and I'll show you how the application looks like. This is my browser, guys. I'll just go to localhost port 8123/users. So here we can find all the users with their email ID and phone number. So this is how our application looks like, guys. So now I'm going to tell you how to Dockerize our microservices. So here we have a microservice which we can run on a development box as long as it has a compatible version of Node.js installed. What we would like to do is set up our service so that we can create a Docker image from it, allowing us to deploy our services anywhere which supports Docker. And one way to do is to create a Docker file. So as I've told you earlier as well during the use case that we write complex requirements for a project or a microservice and an easy to write Docker files. So this Docker file is what I'm talking about right now. So a Docker file is a recipe that tells Docker engine how to build your image. We'll create a simple Docker file in our user service directory and start to explore how we can adapt it to our needs. So I've already done that. Let me just quickly show you where it is present. So I'll just quickly go to that particular directory where I've already written that. Yeah, let me just hit an ls command and you can find that we have test database and user service here as well. Apart from that, we have a compose.yaml file and integration test, which I'm going to tell you about later. You don't have to worry about it right now. Let's just talk about Docker file. So we'll go to this user service. All right. So let me just go there, clear my terminal. And you can see that we have a Docker file present here. As you can see that we have a Docker file present here. So let me just quickly show you the contents of this Docker file. So what we have done here, first of all, we are telling Docker to use Node 4 as a base image. CMD command tells Docker that this image should run the node executable. When the executable terminates, the container shuts down. Then what we have done, we have made use of add command to copy everything. All right. So you can see that we have an add command here. So copy everything in the current directory to a folder in the container called app. We then use run to run a command in this image, which installs our modules. And finally, we expose the server port 8123, telling Docker we intend to support inbound connections on 8123, then run our server code. So this is how our Docker file looks like. Now let me just go ahead and close it. Similarly, I've written the Docker file for my test database as well. So let me just quickly go to that particular directory. So here in the test database, we can currently see when we hit an ls command that we have two files. One is Docker file, setup.sql file, but I have actually told you to create start.sh and stop.sh as well along with setup.sql. There was no Docker file. So now that we are not familiar with Docker, we can improve on this looking onto MySQL image documentation on the Docker Hub. There's a note which tells us the .sql or .sh file added to the images folder will be executed when setting up the DB. So what I've done, basically, I have replaced my start.sh and stop.sh scripts with Dockerfile. All right, so let me just quickly show you how the Docker file here looks like. It's pretty easy, although. Let me just open it through gedit. So we use MySQL 5 as my base image. After that, I've given the password for my database, then the name, then the service, and then the MySQL password. Password is 123. Add setup.sql to docker entry point init db.d. So over here, I've just written that to use MySQL 5 as my base image, then provided the root password, database name, user service. Then we have provided the MySQL password, and then we have used the add command. Let me just quickly save it and close it. So that was pretty basic, guys, writing a Docker file. Now, once we have written these Docker files, what we can do is we can make use of a command called docker build -t test database. So docker build -t test database. So this command docker build -t test database will actually build a new image from the Docker file that you can see over here, right? So it will build a new image from that particular Docker file. Similarly, if I type in here instead of build, if I type in here run -it test database, so this will run a container with this image. All right, so it will basically run a container with this image. The previous command that I've showed you will build an image from the Docker file, and this will run a container from that particular image. This is why we use Docker files. Let me just quickly go ahead and clear my terminal. And now I'm going to talk about composing. So building and running each container is still somewhat, time consuming. We can take things a step further with Docker Compose tool, which I've discussed during the slides as well. So Docker Compose lets you create a file which defines each container in your system, the relationship between them, and build or run them all. If you're facing any difficulties in installing Docker Compose, I'll leave a link in the chat box. People who are watching it on YouTube can see the link in the description box below. Now what we need to do is create a new file in the root of your project called docker-compose.yaml. So it's a YAML file. Let me just go back and hit an ls command here. And you can see that we have docker-compose.yaml file present. So let me just quickly take you through that particular file. I'll use gedit in order to, open that file. You can use whatever editor, or you can even use a cat command to open that on the terminal. Let me just increase the size of it. Yeah. So I've written all the Docker files that I first want to build and create an image, and linking the different Docker images or the Docker container. So you can see that I have services here, user service, and build will basically, I need to specify build value for each of our service tells Docker where to go and find that particular Docker file. So the first one is ./users-service. The name of the container is user_service, and the port that is present here. It should be linked to my database, right? Depends on the database. Environment is database_host is equal to DB. Similarly, my database image can be built using the Docker file, which is present in test_database. So it is pretty basic. Let me just quickly save it and close it. Let me just clear my terminal again. So I need to sign in as a root user. So for that, I'm just going to type in here the password. So now what I'm going to do, I'm just going to type in here docker-compose build. So this will build the Docker images for me. So it is successfully built. Now let me just clear my terminal, and now I'm going to run this application. So for that, I'm going to type in here docker-compose up. That's all I have to do. And here we go. So server started successfully running on port 8123. So let me open my browser and check whether it's working or not. Localhost 8123/user. So as you can see, that application is working here. Here I have all the email IDs and the phone numbers which are there in my setup.sql file. So by this, we come to the end of this use case. Let me open my slides and I'll continue from there. So Edureka provides online structured training on microservices. You can find the course content in front of your screen. And for rest of the details, I'll quickly open my browser and I'll show you the course landing page for microservices. So this is the website, guys. That is edureka.co/microservice architecture training. Over here, you can find all the details like the upcoming batches, what is the course curriculum, course description, project, certification, reviews, and then even the course fees. Pretty much everything related to the course, you can find it here. For all of those who are watching this video on YouTube, you can mention your email ID in the comment section if you're looking for structured training on microservices. Thank you and have a great day.